of Mathematics 1. I am Hitesh Manglani, Assistant Professor at LJ Institute of Engineering and Technology. So today we will discuss topic that is Eigenvalues and Eigenvectors of chapter System of Linear Equations and Matrices. So first of all we will discuss what is Eigenvalue and Eigenvector. So let A be a square matrix of order n, and if there exists a non-zero column matrix capital X and a scalar lambda such that A into capital X is equal to lambda into capital X, then lambda is called eigenvalue of matrix A, and a non-zero column matrix capital X is called an eigenvector corresponding to lambda. Now we will discuss example. So first example, find the eigenvalues and corresponding eigenvectors for A is equal to 8 minus 6 2, then minus 6 7 minus 4 2 minus 4 3. So here we will have to find the eigenvalues and eigenvectors for this matrix. So first of all, the characteristic equation of a square matrix A of order 3 is given by lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0, where s1 is equal to sum of principal diagonal elements of A, and which is also called trace of the given matrix. So it will be 8 plus 7 plus 3, so it will be 18. So value of s1 is 18. Now we will find out s2. So s2 is equal to sum of minors of principal diagonal elements of A. So here we will have to find the minors of principal diagonal elements. So first of all we will find the minor of 8. So if we have to find the minor of 8, then here 8 lies in first row and first column. So we will hide first row and first column. So matrix will be 7 minus 4 minus 4 3. So we will take determinant of this matrix. So it will be determinant of 7 minus 4 minus 4 3. Now we will have to find minor of 7. So here 7 lies in second row and in second column. So we will hide second row and second column. So matrix will be 8 2 2 3. So we will take determinant of this matrix. So it will be determinant of 8 2 2 3 plus now we will find the minor of 3, and 3 lies in third row and third column. So we will hide third row and third column. So matrix will be 8 minus 6 minus 6 7. So we will take determinant of this matrix. So it will be determinant 8 minus 6 minus 6 7. Now if we take determinant of this, then here 21 minus 16, so it will be 5, plus 24 minus 4, so it will be 20, plus 56 minus 36, so it will be 20. So 20 plus 20 plus 5, so it will be 45. So value of S2 is 45. Now we will find out S3, which is equal to determinant of matrix. So we will have to find determinant of given matrix. So it will be 8 in bracket 21 minus 16 plus 6 in bracket minus 18 plus 8 plus 2 in bracket 24 minus 14. So if we simplify this, then 8 into 5, so it will be 40, then 6 into minus 10, so it will be minus 60, then 2 into 10, so it will be 20. So 40 minus 60, it will be minus 20, minus 20 plus 20, so it will be 0. Therefore value of S3 is 0. Now, as we know that the characteristic equation of a square matrix of order 3 is given by lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0. Now we will put the values of s1, s2 and s3 in this equation. So it will be lambda cube minus 18 lambda square plus 45 lambda is equal to 0. So here taking lambda common from these three terms, so it will be lambda in bracket lambda square minus 18 lambda plus 45 is equal to 0. Now here we will factorize lambda square minus 18 lambda plus 45. So if we factorize this, then factors are lambda minus 3, lambda minus 15. So here it will be lambda into lambda minus 3 into lambda minus 15 is equal to 0. Therefore lambda will be 0 or 3 or 15. Therefore, eigenvalues of A are 0, 3 and 15. Now here you can see that sum of this eigenvalue is same as trace of matrix and product of this eigenvalue is same as determinant of matrix. So this way we can verify the eigenvalues. Now we will have to find the eigenvectors corresponding to each eigenvalue. Now we will find eigenvectors corresponding to these eigenvalues. So first of all we will find eigenvector for lambda equal to 0. So here, according to the definition of eigenvector, A minus lambda I into capital X is equal to 0, where capital X is called eigenvector. So first of all, A minus lambda I. So meaning of A minus lambda I, we will have to subtract lambda from principal diagonal elements. And here, lambda is 0. Therefore, principal diagonal elements will be same because 8 minus 0 will be 8, then 7 minus 0 will be 7, then 3 minus 0 will be 3. Therefore, it will be 8 minus 6, 2, minus 6, 7, minus 4, 2, minus 4, 3. And into capital X, so which is a non-zero column vector, so here it can be written as x, y, z is equal to 0, 0, 0 because right hand side it is 0. So here, if we write the equation from this matrix, then first equation will be 8x minus 6y plus 2z is equal to 0. And second equation will be minus 6x plus 7y minus 4z is equal to 0. Then third equation will be 2x minus 4y plus 3z is equal to 0. Now taking first two equations, so first equation is 4x minus 3y plus z is equal to 0. And second equation is 6x minus 7y plus 4z is equal to 0. Now here we will apply Kramer's rule for these two equations. By Kramer's rule, x divided by determinant of minus 3, 1, minus 7, 4. So here if we have to write for x, then we will hide x and write the coefficients of y and z. Is equal to minus y divided by determinant of 4, 1, 6, 4. So here if we have to write down for y, then we will hide y and write down the coefficients of x and z is equal to z divided by determinant of 4 minus 3, 6 minus 7. So here if we have to write down for z, then we will hide z and write down the coefficients of x and y. Now if we simplify this, then it will be x divided by minus 12 plus 7, so it will be minus 5 is equal to minus y divided by 16 minus 6, so it will be 10 is equal to z divided by minus 28 plus 18, so it will be minus 10. So if we simplify this, then it will be x divided by minus 1 is equal to y divided by minus 2 is equal to z divided by minus 2. Because here we have divided this result by 5. Suppose this is equal to t1. Therefore, x divided by minus 1 is equal to y divided by minus 2 is equal to z divided by minus 2 is equal to t1. So here capital X is equal to x, y, z. So here x will be minus t1 and y will be minus 2t1 and z will be minus 2t1. So here taking t1 common, so it will be minus 1, minus 2, minus 2. So this can be written as t1 into capital X1, where capital X1 is an eigenvector corresponding to lambda is equal to 0. So this is how we can find out eigenvector corresponding to eigenvalue. Now we will repeat this same process for remaining eigenvalues. Now we will find out eigenvector for the eigenvalue lambda equal to 3. So A minus lambda I into capital X is equal to 0, where capital X is eigenvector. So A minus lambda I, its meaning is we will have to subtract lambda from principal diagonal elements. So here lambda is 3, so here 8 minus 3 will be 5, then 7 minus 3 will be 4, then 3 minus 3 will be 0. Therefore matrix will be 5 minus 6 2, minus 6 4 minus 4, then 2 minus 4 0, and capital X is x, y, z is equal to 0 0 0. Now if we write equations from this, then first equation will be 5x minus 6y plus 2z is equal to 0, and second equation will be minus 6x plus 4y minus 4z is equal to 0, and third equation will be 2x minus 4y plus 0z is equal to 0. Now taking first two equations, so first equation is 5x minus 6y plus 2z is equal to 0, and second equation is 3x minus 2y plus 2z is equal to 0. Now here we will apply Kramer's rule. So by Kramer's rule, x divided by determinant of minus 6 to minus 2, 2. So here if we have to write down for x, so here for x we will hide x, and here we will write down the coefficients of y and z. That is equal to minus y divided by determinant of 5, 2, 3, 2. Now here if we have to write down for y, then we will hide y and we will write down the coefficients of x and z. And that is equal to z divided by determinant of 5 minus 6, 3 minus 2. So here if we have to write down for z, then we will hide z and we will write down the coefficients of x and y. So here if we simplify this, then here x divided by minus 12 plus 4, so it will be minus 8 is equal to minus y divided by 10 minus 6, so it will be 4 is equal to z divided by minus 10 plus 18, so 8. So here if we divide by 4, then it will be x divided by minus 2 is equal to y divided by minus 1 is equal to z divided by 2, and that is equal to t2. So capital X is equal to x, y, z, and here value of x is minus 2t2, value of y is minus t2, and value of z is 2t2, and here taking t2 common, so it will be minus 2 minus 1 2. So this can be written as t2 into capital X2, where capital X2 is an eigenvector corresponding to eigenvalue lambda equal to 3. Now same way we will find out the eigenvector for eigenvalue lambda equal to 50. So here a minus lambda I into capital X is equal to 0, where capital X is eigenvector. So here we will have to find out a minus lambda I. Now for that we will have to subtract lambda from principal diagonal elements of matrix. So here lambda is 15. So 8 minus 15 will be minus 7, then 7 minus 15 will be minus 8, then 3 minus 15 will be minus 12. So matrix will be minus 7, minus 6, 2, then minus 6, minus 8, minus 4, then 2, minus 4, minus 12, and capital X is x, y, z is equal to 0, 0, 0. Now if we write down the equation from this matrix, then first equation will be minus 7x minus 6y plus 2z is equal to 0. Then second equation will be minus 6x minus 8y minus 4z is equal to 0. And third equation will be 2x minus 4y minus 12z is equal to 0. Now taking first two equations. So first equation is minus 7x minus 6y plus 2z is equal to 0. And second equation will be 3x plus 4y plus 2z is equal to 0. Now here we will use Kramer's rule. So by Kramer's rule, x divided by determinant of minus 6, 2, 4, 2 is equal to minus 5 divided by determinant of minus 7, 2, 3, 2 is equal to z divided by determinant of minus 7, minus 6, 3, 4. So here if we have to write down for x, then we will hide x and we will write down the coefficients of y and z, and here if we have to write down for y, then we will hide y and we will write down coefficients of x and z, and here if we have to write down for z, then we will hide z and we will write down coefficients of x and y. So if we simplify this, then x divided by minus 12 minus 8, so it will be minus 20 is equal to minus 5 divided by minus 14 minus 6, so it will be minus 20 is equal to z divided by minus 28 plus 18, so it will be minus 10. Now if we simplify this by dividing it by minus 10, so it will be x divided by 2 is equal to y divided by minus 2 is equal to z divided by 1, and that is equal to t3. So here capital X is equal to x, y, z, and x is 2t3 and y is minus 2t3 and z is t3. So here taking t3 common, so it will be t3 into 2 minus 2, 1, and it can be written as t3 into capital X3, where capital X3 is an eigenvector corresponding to eigenvalue lambda equal to 50. So this is how we can find out eigenvalues and eigenvectors. So in today's lecture, we have discussed about eigenvalues and eigenvectors and how to find eigenvalues and eigenvectors of matrix A. Thank you for watching this lecture. I will see you in the next lecture.